Hello everyone, welcome back. We are doing operations management, new day, new topic. We last time I think we finished with queuing theory if I'm correct. And now we move into the next topic for operation management. And now slowly we are moving into hypothetical concepts. Now, not exactly hypothetical concepts, but concepts that are not done on the physical subject. Like when we were doing production planning, we knew that there is a machine, and then, or rather, we were doing mathematical concepts. We are going to do less of mathematical concepts now, and we are going to move towards statistical concepts. And statistical concepts are concepts that are going to help us do estimations, that are going to help us use previous data in prediction of the future. So this is going to be very little exact values, and it's going to be more approximations that we are going to draw out of the data that we have. The topic that we are going to do today is called simulation. Now in simulation, there are a lot of simulation techniques. What we are going to do is we are going to do a method called Monte Carlo simulation. Now, because I like doing this, a little brief history about simulation or Monte Carlo simulation. Well, let's first start with simulation. Simulation. The word simulation literally means imitation. What do you mean by imitation? You try to imitate your surroundings. You try to imitate something and create an artificial world out of it. Like for example, if you have ever been to a building construction project where the building construction work is going on, in such building construction work projects, they will always have a size model or a ratio size model put up in the construction center to show to people that, oh, this is how that it is going to look. So what are you doing? You are simulating or you are imitating the actual by creating an artificial, not an artificial, but a 2-scale model out of it. Well, another example of this or another example of simulation is, if you've ever played them, they are called simulator games. Now, almost all games coming out of late are simulator games. What are these simulator games? These simulator games are nothing else but the games that we play today that are trying to become so realistic that you feel like you are part of the game. They are trying to imitate or simulate the conditions of the game so much that after a while you feel like you are a part of the game. The world renowned game, and which I'm very happy about the ban about, and that is PUBG. You have no idea how happy this makes me to know that this game has been banned. Having said that, not because it's Chinese, never cared, majorly because the amount of time that people waste doing this, which could have been sleep for all I care. Just get 12 hours of sleep instead of sleeping for 6 hours and playing this game for 6 hours. Hello. Anyway, coming back to, so what is this game? This game is a game where they have tried to create such realistic situations that you actually start feeling like a part of the game. And when you see these games or these kind of games, or these, you call it first player games, second player games, third player games, when you look at these first player interfaces over the years, right from, so Counter-Strike was my PUBG, or it was when we were in school that we used to play Counter-Strike. After Counter-Strike, there came a lot of games. Then there was Black Ops, then there was PlayStations, and on PlayStations we played games like Far Cry or Call of Duty and stuff like that. And then we are now into another completely new phase, which is called virtual reality. Virtual reality is so realistic that you actually feel that you are a part of the system. But are you actually in a war zone? No, no. We've just tried to imitate the war zone so well that you feel like you are a part of the war zone. And that is nothing else but simulation. Sir, how is that going to help us? I will tell you, just understand what simulation is. The Ludo that you are playing, is nothing else but it is a simulation of the actual game Ludo. Where the only difference is you are playing it on a virtual platform. So it's nothing else but a simulator game of the actual game Ludo. I don't like playing it for a simple reason that back in my day when we were kids, if you are playing Ludo and you are losing, well, the best thing to do is get up and bump the game. The game ends right there. But unfortunately, you can't do that with a cell phone. Hence, I don't play Ludo. But yeah, coming back to jokes apart, coming back to the topic, what are all these? These are simulations. What are we trying to do? We are trying to imitate the surroundings to create a realistic surrounding. And that is nothing else but simulation. Like a very good example of this would be when you are sending a pilot, or let's say you're sending an astronaut to the moon. You just don't call that person up one day and say, "Kal jane ka hai, 5 baje ready raho." Hello? No. There is so much training that goes through it. That person has to sit in a simulated, you can call it a cabin or a simulated capsule that will be the same like the aircraft that the person will fly to the moon. He will experience zero gravity in it. Why are we doing this? So that the person gets used to the actual situation, or the person realizes that, oh, this I can't do in this situation, so I have to figure out a different way of doing it. Like something as simple as a pen. I don't know if you know this. I don't know if you know this, but these pens that we use, I'm a science student, so I'm sorry if I'm boring you with all this. These pens that we use, if you see this refill, I don't know how my camera points, it just keeps going away. Anyway, yes, these pens that we use, these refills actually work with gravity. What happens is when the refill is upside down into the pen, gravity pushes the ink down. If you ever try to sleep and write, or try to write against a wall, the pen will write for some time and then stop working. When you are in zero gravity, when there is no gravity on the moon, or there's very little gravity off the moon rather, the pen will stop working. Then if I want to take notes, how will I take notes? And this they realized in a simulated environment, that a normal pen does not write in a zero gravity environment. Tomorrow, if I have to train a pilot, I just don't give him the key and say, "Ye lo, uda ke aao." No. I create a simulated cockpit that looks exactly and has all the features of a real cockpit where the person practices. Now here, for the glass in front of you, the person will have a screen that will show you how the plane is flying. If you crash here, it's okay because it's just a simulation. It's not an actual plane. But if you actually crash an actual plane, you will kill a lot of people. And that is why once I'm sure on a simulated platform that this will work, then and only then I move to a natural platform. Another way of looking at it is when I actually try to do something and it fails, it might cost me a lot of money. So what I do is I do it in a simulated atmosphere and then check how it will work and then apply it into real life, so that I have learned what will work, what will not work, what could I do better, what could I change in certain way or the other. Now the simulation that we are going to do is called Monte Carlo simulation. Now it is not two people by the name Monte and Carlo who defined the simulation. Simulation is rather one technique that was not defined by one person, and that is why I think simulation is that technique that has immense applications, from estimations of means to simulation is applied into integration, in finding area under the curve, in numerical methods. Simulation has mad applications. We are going to do just one application of it, which is the probabilistic application that we are going to do. Well, having said that, then where does the name Monte Carlo simulation come into picture? Well, simulation was designed by three physicists. I remember the name of two. One was Ulan and the other was Newman. I don't remember the third one. And this was somewhere around the World War II, if I'm correct. So this was somewhere around the 1930s and the 1940s. So the late 30s and the early 40s is where simulation was developed. What is simulation, or what are we going to do in simulation? See, like I said, the word simulation means you imitate. And surprisingly enough, this is one technique that was developed by gambling, for gambling. Yes, you heard me right. This was developed, or the seed of this idea came out of gambling. Like for example, suppose you are I don't know the games that you are familiar with, but it's a game like poker or a game like blackjack. When I'm playing these games, if you've done mathematics 11th and 12th, we've done something called permutations and combinations, and these games depend a lot on permutations and combinations. So suppose if I want to keep playing blackjack and I want to find out that if I play like a 10,000 games, how many of the outputs of these 10,000 games are going to be in my favor? Well, to be able to do that, I can't sit and play 10,000 games. Imagine the kind of time it requires to play 10,000 games. And that is where what I will do is I will create a computer simulated program that in seconds, well now in seconds, back in the 1930s and the 1940s, where we were still working on UNIVACs, back then these games simulations took a lot of time, but it still didn't take as much time as it would take to actually play the game. So if actually playing 10,000 games would, let's take at least 50 or 60 days, this could have been done in like hour and a half, 2 hours tops. This simulation software or the simulation program will run and give you outputs and tell you that on an average what are the cards that you will see, on an average what will happen in this game. And that is why simulation is used. What simulation does is simulation imitates the process over and over again, where you're not actually doing the process. You are doing the process mathematically, not actually. You are doing the process statistically, not actually. You will do the process mathematically and get different results out of it and get an average value for that result. Or in other words, in statistics, an average value is also called an expected value or an expectation of the variable x. And that is where simulation was used. So simulation, frankly, was used when they wanted to get the different kinds of outcomes of the game solitaire, the different types of outcomes of the game, the roulette. Sorry for my handwriting, but yeah, the game roulette. I hope you know what the roulette is. They are in all casinos. There's a huge, there's like a circular disc that you turn around that has black and red boxes where you bet on a certain number and a certain color. The guy drops the marble in it. The marble keeps going around the circumference and after a while it stops on a certain number. If you get the number, you win. If you don't get the number, you lose. That is how roulette works. There's something called as Russian roulette. Do not Google it. Anyway, coming back to, so yes, so why did they develop is basically gambling. And then from that come concepts like the gambler's fallacy and the gambler's gain and a fair game and an unfair game and so on. It's a very interesting subject and I've already wasted like 15 minutes talking about it when it's not required. But anyway, you get the idea of what and why simulation was developed. So coming to the bottom of it, Ulan, our physicist here, who was a part of developing simulation, had an uncle who had a gambling problem. And his uncle went to a casino called the Monte Carlo Casino in Monaco, or like we would call it, Monaco. We are Indian. We have a mix of British English and American English. Anyway, this is I think Monaco shares a border or water with France, if I'm correct. Yeah. So this is somewhere in Europe where Ulan's uncle, who had a gambling problem, from where Ulan decided to understand whether actually gambling is a good idea or a bad idea. So he tried to mathematically understand gambling, and because the idea came from his uncle, he decided to name the process after his uncle's favorite casino, and that is the Monte Carlo Casino in Monaco. What are we going to do here? So what I'm going to do is I'm going to do a question with you, and I'm going to show you the process. And so this is the kind of a question where until unless I don't show you what we are doing, I can't tell you why we are doing it. So I'm going to do one question, I'm going to read the question out to you, I'm going to tell you what the question means, and so on. So what are we basically going to do? See, simulation is imitating. Imitating what? Imitating the environment and then deriving results out of it. So what we are going to do is we are going to use past data, try and analyze the data mathematically, and mathematically imitate the situation and mathematically predict the future of this situation. So it's a mix of forecasting and it's a mix of time and motion study. So the best thing about simulation is it can be applied in major fields, like in a lot of fields. You can do forecasting also with simulation. But if a better mathematical model fits on forecasting, we use the better mathematical model there. Simulation, on the other hand, is used for experiments that are not standard. Now, forecasting becomes like a standard experiment. Every company requires a forecast. So we developed a forecasting mechanism. Here we are going to do questions that might not have standards of working towards them. So, like I said, let's do one question and then I will explain to you what the process is or why we do whatever we do. So this is simulation. Question number 1. In your modules it is page 94, question number 13. And there's another very funny thing about simulation which I'll tell you in the course of time. A confectioner sells confectionery items. A confectioner sells confectionery items. Starting with what a confectioner is. A confectioner is basically, or a confectionery store is basically a sweet store. People who deal with a lot of sugar and milk and chocolate and stuff like that. So a confectioner sells confectionery items. Past data of demand per week in 100 kilograms with frequency is given below. So a confectioner sells confectionery items. Past data of demand per week. Like I told you, we'll always be working with past data. Past data of demand per week in 100 kilograms with frequency is given below. So what have they given you? They have given you the demand of that commodity, which if you notice is 0, 5, 10, 15, 20, 25. And how many times did that demand come up? So a demand of 0 came down twice. A demand of 5 came 11 times. A demand of 10 is in kilograms, yes, came 8 times. A demand of 15 came 21 times. A demand of 20 came 5 times. And a demand of 25 came 3 times. Now you have done this demand per week in hundreds of kilograms. Okay. Using the following sequence of random numbers, generate a demand for the next 10 weeks. Also find the average demand per week. See, finding the average demand is not difficult. We've done this in the 11th and the 12th, or we've done this in FY BCom, where for a frequency distributed data, I can find the mean. So all you do is multiply your demand with the frequency, take a sum of it, divided by the total frequency, and that's your answer. That's your average demand, which will fall somewhere between 0 to 25. So somewhere in the center. So my guess is going to be, it will fall somewhere in the 10 to 15 kg bracket. So my guess would be somewhere around the 13.5 bracket. But the problem is, they don't want you to find the average by that average method. What they want you to do is, they want you to generate a demand for the next 10 weeks. Now, how does one generate a demand for the next 10 weeks? And they have given you something called as a sequence of random numbers. What is that? How is that going to be of my help? So, like I said, I will explain everything to you, but one step at a time. Step 1, let's write down the demand and the frequency data. So let me write that down and get my sheet ready. Now, after writing down the demand and the frequency, the first thing that you do is, I cannot work with frequency. I can work with probability. So what I'm going to do is, I'm going to change frequency to probability. Now, how does one change frequency to probability? If you've done this and you must have done this in FY BCom, and that is, or if you've done math in the 11th and the 12th, frequency of a certain event or the chance of that event happening is nothing else but how many times does the event happen out of the total. So number one, let's take a total. What is the total number of events? Well, it is 2 plus 11 plus 8 plus 21 plus 5 plus 3 is a total of 50. Now, if I want to change frequency to probability, what I'm going to do is, I'm going to start dividing all the frequencies by the total, which is 50. So 2 divided by 50. Now the good thing is 50 is a good number and you can do this in the calculator, but let me tell you a simpler way of doing this. See, when I do 2 divided by 50, something like this, or any number that I have to divide by 50 now. So when I have to divide that number by 50, instead what I will do is, I will multiply the numerator by 2 and the denominator by 2. So A into 2 upon 100 is what it becomes. So basically double the number and then put a decimal 2 places to the left. So 2 into 2 is 4. So this will be 0.04. 11 into 2 is 22. So this will be 0.22. 8 into 2 is 16. So 0.16. 21 into 2 will be 0.42. 5 into 2 will be 0.10. 3 into 2 will be 0.06. The total of all the frequencies is 50. The total of all the probabilities should always be 1. If it is not 1, you've made some kind of a mistake. All these, if you've done math level 12, all these sets together should exhaust the sample space. And if they exhaust the sample space, the total of their probabilities always has to be 1. So let's check 0.04 so that I'm sure that my probabilities are also correct. 0.22, 0.16, 0.42, 0.10, 0.06. The answer is 1. That is what I was expecting. So the total is 1. So sometimes they might give you probabilities itself. Then this change is not required. If they don't give you the probabilities, then and only then is the change required. So step 1. Data will be given to you and the probability or the frequency of the data will be given to you. If the frequency is given, change it to probability. Once you've changed the frequency to probability, your next task or your next job is going to be, and this when I tell you, I want you to do this for yourself. You will not write this down. Multiply every value by 100. What did I say? Multiply every value by 100. Now it's up to you if you want to actually write it. If you don't want to write it, it's up to you. Or then first do one thing. So step 1, if there is frequency, change it to probability. And once you have probability, cumulate the probabilities. How do you cumulate the probabilities? Well, the first probability is written as and how it is. Now for the next one, start adding. So you will say 0.22 plus 0.04 is 0.26. 0.26 plus 0.16 is going to be 6 plus 6 is 12, 1 and 2. So 0.42. 0.42 plus 0.42 is going to be 0.84. 0.84 plus 0.10 is 0.94 and lastly 0.94 plus 0.06 is 1. This should tally. Now like I said, this is for you. You will not actually do this. After this, you will very snidely and quietly multiply every value by 100. 0.04 into 100 will be 4. This will be 26. This will be 42. this will be 84, this will be 94, and this will be 100. So let me repeat this, and this has to be done in every question. Every question will have these two tables in them. This is the first table. What will you do? The data, which in this case is demand in per weeks, it could be anything. It could be anything. And the frequency or the probability for that data will be given to you. If there is frequency given, you change it to probability. Once you change frequency to probability, you cumulate the probability, and this is only for you. You will multiply it by 100. Now we will start creating something called as a range. What do you mean by range? Well, range is nothing else but something that says from this value to this value is range. The first data set, no matter what it is, not because this is 0, always. The first value start at 0 and end at one value before the 4. What is one value before the 4? One value before the 4 is 3. So you stop at 3. For the next, here you stopped at 3 because it was 4 here. You start at 4 and stop one value before, which is 25. Next, you start at 26 and stop one value before, 41. You start at 42 and stop one value before, which is 83. You start at 84 and stop one value before, which is 93. You start at 94 and stop one value before, which is 99. Let me quickly repeat this, and this remains standard in each and every question. You will be given a data set. In this case, it is demand. There will be a frequency or a probability given to you. If there is frequency, change it to probability. If it is probability already, fantastic. Cumulate the probability in your head or with a pencil on the side, multiplied by 100. Start creating a range, and that is from 0 to 3. From 4 to 25. So start one value later and end one value before. So 25, 26, 42, 41, 41, 42, 84, 83, 83, 84, 94, 93, 93, 94, 94, 99, 99, 100. This is step 1. And like I said, this has to be done in each and every question. We move on to step number 2. Now we come to the second part of this table, or we come to the second table that we have to draw. So like I said, the first table was, we had the data, we had the frequency, change it to probability, cumulated, multiplied by 100, create a range. Because after these, a lot of questions, I'm not going to sit and show you all of this. I'm directly going to do it and then show you my values. That's it. That's all that I'm going to show you. So after having this, what we do in the next step is we go to the next part of the table. Now for the next part of the table, what all do you require? I'll tell you. So the question said that you are giving me these random numbers and you are asking me to generate a demand for the next 10 weeks. So check how many random numbers are given. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wow. Why did you give me 15 numbers then if you are asking me to generate for 10 weeks? Well, that's okay. Sometimes they give you extra. So what will you do? You will take only 10 random numbers because they want for only 10 weeks. What are we doing? I will tell you. Just humor me and listen to what I'm saying. We want to estimate a demand for 10 weeks. So we need only 10 random numbers. But sir, they've given 15. Now which 10? Any 10 I can take? No. You have to always go in a line and you have to read them horizontally like this. So 35, 52, 13, 90, 23, 73, 34, 57, 35, 83, 94, 56, 67, 66, 60. That is how the order will go. But I want only 10. So I will take 1, 2, I will take 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. I will only stick to these. I will not take these rest of the 5. So now what I will do is I will draw a table and get a table ready for the next part. So I have my table ready. What do I have in this table? Well, I have week because you said 10 weeks. And in these 10 weeks, I will write the random numbers, but which I will write the 10 random numbers that they have given me. Okay. Let me highlight the 10 random numbers. So they've given 15, but I will only take the first 10. I'm sorry about that. My phone is acting up today. 35, 52, 13, 90, 23, 73, 34, 57, 35 and 83. These are the 10 random numbers. Now, I want you to listen to what is going to happen or how does this work. These random numbers will help me randomly estimate what could be the demand for the first week. So I am trying to imitate or I am trying to simulate the demand for the first week with the help of this random number. But sir, how will that work? Look at this. All random numbers are 2-digit. Correct? So they're basically either 1-digit or 2-digit. So basically random numbers start from 0, go up till 99. If you notice, your range is also from 0 up till 99. And there's something about this range. And that is, if the probability of something is small. See, zero demand only happens twice in 50 weeks. Or there is only a 4% chance of a zero demand. So do you agree the range is small or the range only incorporates 4 numbers? 0, 1, 2, 3. If the demand has a good probability, which is it is a 22% chance that the demand will be 5 kgs, then this range will have 22 numbers in it. Check. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Doesn't this range from 4 to 25 incorporate or include a total of 22 numbers? So can I say higher the frequency, higher the probability and higher the range or bigger the range? Smaller the frequency or lesser the demand, lesser the probability and smaller will be the range. So the bigger the range, more random numbers will fit in it. The smaller the range, less random numbers will fit in it. So I will now use these random numbers to project what the demand could be. How? And this also remains standard. These two tables are standard in every simulation question. There is no simulation question that does not have these two. If at all there is a change, there will be a change after this. So in week 1, the random number is 35. You ask yourself, in which range does 35 fit? Well, 35 fits in 26 to 41. So in the range 26 to 41, 35 fits. Check what is the demand for 26 to 41. Well, the demand is 10. So the demand for the first week will be 10 units. For the second week, the random number is 52. Where does 52 lie? Well, 52 lies between 42 to 83. What is the demand for that range? And the demand is 15. So the answer is 15. The next random number for the third week is 13. Where does 13 lie? Between 4 to 25. And for 4 to 25, the demand is 5. So the answer is 5. The random number 90, I'm sorry about that. The random number 90 lies in 84 to 93, and 84 to 93 has a demand of 20. So 20, 23, 4 to 25, 5. 73, 42 to 83, 15. 34, 26 to 41, 10. 57, 42 to 83, 15. 35, 46 to 41, 10. And lastly 83, 42 to 83, 15. I'm extremely sorry about this. Done? This is your projected demand for the next 10 weeks. What do you want from me? Now after this is what might change in different questions. Like suppose tomorrow they give you that the train speeds of a few trains is given and the probability of those speeds. Then what they will ask me to estimate is estimate the speed of the train for the next 10 days or the next 10 trips or whatever. So up till here, the question remains the same. Every question has to have the first table for the range and the second table is with the use of the random numbers and the range predict the data. Now after this, what they ask you might change. What have they asked us? Let's come to our sheet. What they have asked us in this question is that using the following sequence of random numbers, generate a demand for the next 10 weeks. Done. Also find out the average demand per week. Oh, average demand is yet to be found out. Fine. I will find you the average demand. Average is nothing else but total divided by the number of readings. So the total here will be, well, 10 plus 15 plus 5 plus 20 plus 5 plus 15 plus 10 plus 15 plus 10 plus 15. The answer is 120. This 120 represents 10 weeks. So if you ask me, average demand is 120 divided by 10, which is 12 per week. And that's my answer. This is the projection for the next 10 weeks and this is the average that you can expect. And like I said, Monte Carlo simulation or simulation in general is used to do nothing else but estimate averages or expected values. So I'm expecting a weekly demand of 12 per week. And that's it. This is what the entire question is. There is nothing else apart from this. That's it. Every question up till here always will remain the same. Data, probability of the data, from the probability accumulated, accumulate the probability, create a range, from the range estimate the values. So where are these random numbers coming from? They are literally random numbers. There are computer programs that help you generate, or if you've ever done a little bit of programming at any point of time in life, or you might do, whenever you are learning a software program, whether it's C, C++, Java, you have to write, for practice, you have to write a few programs. This is one of the programs that we used to write when I was in TY, when I did my bachelor's in mathematics in C. We had like a practical that said, generate a computer program to create 50 random numbers. So you basically write a computer code that when you run will give you 50 random numbers. These numbers will have no relationship between each other. They will have no pattern between each other. Because we are trying to estimate this for a random environment. That is why the numbers used should also be random. Again, I'm sorry about this. Having said that, I'll try to fix this right now. Having said that, Where do these come from? They will give you these. Like we used to have a book. There used to be a random number book where they would tell you refer random number table 46. So we had to take the random numbers from table 46 so that everybody had the same answer. So it becomes easier for checking. When you're actually doing an experiment, you can take random numbers from anywhere. But also said that you have to read them in a certain way. So the random numbers given to you have to be read in that order. You can't change the order of reading them, because if you change the order, maybe your estimation might change and your average might change. So then if everybody has a different answer, it becomes difficult for the teacher to check. So if they would have given me 10, then I would have picked up the 10. But they give me 15, I only have to pick up 10. Let's quickly look at their solution. So here we have it. And that is the frequency, which I changed to probability, and the random numbers. So table number 1, demand, frequency to probability, probability cumulate. If you notice that multiplication of 100 is not written, because I told you that is for you to understand, not for anybody to be seen or shown. Then we create a range. How? So this is 0.04. Basically this is 4. The next question that I want to do. Now, like I told you, the base of every question will remain the same. A few things might change at the end, which is what I'm going to show you from here onwards. Production per day, 95 to 100, probability of that production, and then again production per day. Oh, okay. So the production per day is 95 to 105. It's just one table, and probabilities are given to you. What do you want me to do? Finished cars are transported across the bay at the end of each day by ferry. If the ferry has space for only 101 cars, what will be the average number of cars waiting to be shipped, and what will be the average number of empty spaces on the boat? Use the following random numbers to simulate the data provided above. 20, 63 and so on. Now here they didn't mention use 10 numbers or 5 numbers, which means we have to use all the numbers that are given. Now like I told you, no matter what kind of a question it is, two things remain the same. So you will say, sir, they are asking you something like empty spaces and average number of cars left behind and all of that. I understand. But then see, the baseline of the question remains the same. Step 1 will be changing probabilities to cumulative, cumulative to making a range out of them. After doing that, predicting the production for the next whatever number of periods according to the random numbers given to you. And then we will do whatever they are asking us to do. So these two tables have to be done. You don't have a choice. So let me do one thing. Let me get the first probability table ready. So I have my table ready for production per day and the probabilities for that production. What do we do after this? After this, we cumulate the probabilities. Correct? How do you cumulate the probabilities? The first probability remain as and how it is, and then we start adding the next one. Correct? So 0.03 plus 0.05, this one is easy, 0.08. So 0.08 plus another 0.07 will be a 0.15, 0.25, 0.40, 0.60, 0.75, 0.85, 0.92, 0.97 and 1. And remember, I told you the total of the probabilities will always and always be 1, and that is why you get a cumulative 1. So production per day, probability and cumulative probability. Now after this, remember I told you that the next step is not for you to show, it is only for you to understand. Multiplied by 100. So 3, 8, 15, 25, 40, 60, 75, 85, 92, 97, 100. After doing that, you create your range. Start with 0 and stop one number before this. This is 3. So this will be 0 to 2. Then you will have a 3 to 7, 8 to 14, 15 to 24, 25 to 39, 40 to 59, 60 to 74, 75 to 84, 85 to 91, 92 to 96, 97 to 99. I have done with my range, production per day, probability, cumulative probability, and my range. Remember, I told you no matter what the probabilities are, in the previous question they gave you frequency which you change to probability. Here already it is given as probability only, so you don't really need to worry about it. Now that that is done, we move on to the next part, and that is predicting or imitating or simulating the production for all the random numbers that they have given us. Correct? So let's go back to the question and make a note of everything. So they have given you a certain set of random numbers. With the help of these random numbers, I have to predict the production on that particular day. Is that right? So let's begin then. Let me draw the table and get this ready. So my table is ready. Let's fill in the random numbers. So they have asked you to use these random numbers. I've counted them. There are a total of 15 random numbers. So let me write them down. 20, 63, 46, 16, 45, 41, 44, 66, 87, 26, 78, 40, 29, 92, 21. And now we start estimating the production. Now because this entire thing won't fit on one page, let me unzoom a little. Then only I think everything might fit on one page. Let's check if this works. I think so. Yes, I don't think we need to see the headings. So I think this should be good enough. Let's begin. 20 falls in 15 to 24. The production is 98 units. 63 falls in 60 to 74, 101. 46, 40 to 59, 100. 16, 15 to 24, 98. 45, 40 to 59, 100. 41, 40 to 59, 100. 44, 40 to 59, 100. 66, 60 to 74, 101. 87, 85 to 91, 103. 26, 25 to 39, 99. 78, 102. 40, 100. 29, 99. 92, 104. 21, 98. That's it. That is my simulated production for the next 15 days. What are you asking me to do? Well, you are asking me to do something specific. In the previous question, what did they say? Like I told you, if this was like that question, they would have said that find the average production per day. You would add the total and divide it by 15. That is average production per day. But that is not what they are asking you. What they are asking you is Finished cars are transported across the bay at the end of the day. So at the end of the day, finished cars are transported across the bay by a ferry. What is a ferry? A ferry is nothing else but a transportation boat. A boat used for transportation. So if you are from Bombay, then we go to Alibag, or even at Daman, you have to go from one place to another. There are these small ferries that cover up the certain locality, and that is used for transport for people and sometimes vehicles also. So they have to transport by a boat. If the ferry has space for 101 cars, so the ferry has space for how many cars? 101 cars. What will be the average number of cars waiting to be shipped, and what will be the average number of empty spaces on the boat? See, there are 101 spaces on that ferry. But is it compulsory that I am producing exactly 101? I might have set a standard of 101, but because of different reasons, production is fluctuating. Production goes from 95 units to 105 units. So sometimes I do produce 101, sometimes I produce more than 101, sometimes I produce less than 101. When I produce more than 101, what happens is that there will be a certain number of vehicles or cars that will not be able to ship because space is only 101. And if I produce less than 101, there will be empty space on the ferry because that ferry has a load of how many? 101 cars. Then can I say one thing? Depending on how much am I producing, two situations might arise. Situation number one is there is an empty space left on the boat, and situation number two is a vehicle is left behind. And this is the extra. See, these two tables remain the same for every question. What might change is what they are asking you after this. In the previous question, they asked you to find the average. In this question, they have asked you what are the number of empty spaces and what are the number of cars that were not shipped. So what I will do is I will create two columns. So let me make two columns. So what are the two situations that might arise? Well, the two situations that might arise is number one, an empty space on the boat. So the first situation that might arise is that there is an empty space. I don't have place, that is I only made one. You can make two lines as the heading and write it down. And the other situation that might arise is car waiting, and complete that with car waiting to be shipped. So there are two options. Let's begin. I am producing 98 on day one. If I am producing 98 cars on day one, what is going to happen is there are going to be 3 empty spaces on the boat. Because I am producing lesser than 101. Let's come to number 2. I am producing 101. Well, if I am producing 101, there is no empty space and no car waiting. And remember, either of the two will happen or none of them will happen. Both of them will never happen. Mutually exclusive. You can never have empty space as well as car waiting. That is so stupid. That there was an empty space but there is still one car waiting. That doesn't happen. So one of them will happen or none of them will happen. Let's come to the 3. If 100 cars are produced that day, then there will be one empty space. There will not be a car waiting. Again, for 98, 3 empty spaces, none waiting. 100, 1, none waiting, 1, none waiting, 1, none waiting, none waiting, none waiting, none waiting and none empty, because exact 101 production. 103. There will not be an empty space, but there will be 2 cars that will be waiting. Now the next question is, sir, are we supposed to set this off with this? No. See, this is not actual production that is happening. We are using mathematics to just get average values. So I am not going to set it off. When will I set it off? When I'm actually producing. This is not actual production. This is just simulation. If they would have told you to set it off, then I would have. But they are not asking you to set it off. Which means I will just make a note of, if the production is this, what might happen. And that's it. So, with 99 vehicles, there will be 2 empty spaces, no waiting. With 102, there will not be an empty space. There will be 1 car that is waiting. 100, there will be 1 empty space, none waiting. 99, there will be 2 empty spaces, none waiting. 104, there will be no empty space, but 3 cars will be waiting. And 98, there will be 3 empty spaces and no car waiting. That is it. I have calculated the number of empty spaces and the number of car waiting. Let me take a total. Empty spaces. 1 plus 3 is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 empty spaces. And what about car waiting? 2, 3, 4, 5, 6. There are 6 cars that are waiting. So 15 empty spaces in total and 6 cars that are waiting. Let me check that once again. So, oh sorry, I missed this 3 and this 1 if I am correct. Yes? 3, 4, no, I only missed this 3. So this should be 18, I'm sorry. 3, put a dash here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18. I'm sorry about that. 18. What are you asking me? You asked me 2 things. Average number of empty spaces and average number of cars waiting. Average in both or average in only one? What are they asking you? Average number of cars waiting to be shipped and what will be the average number of empty spaces. So they're asking you average of both. So average cars waiting is, what is the total car waiting? Total car, there are 6 cars that are waiting. So this 6 will be divided amongst all the 15 days. But sir, why will I consider these dashes? That is not a dash, that is 0. So when you are adding data, you are actually adding the zeros also. So this 6 will be shared with everyone. So it is 6 divided by 15. What is 6 divided by 15? 6 divided by 15 is 0.4. Next, average empty spaces. Total 18 empty spaces in a span of 15 days. Average empty space. Average empty space is 18 divided by 15. 18 divided by 15 is 1.2. When will this come in handy? Tomorrow, if somebody suggests or a manager suggests that, sir, why don't we buy a ferry with a capacity of 105? Well, I'll tell him, dude, with 101 capacity, we are still on an average of 1.5 empty spaces. There is just a 0.4 car waiting. The waiting is much less as compared to the empty. If you buy a 2 or 3 more space worth ferry, or you create 2 or more spaces on the ferry, what's the point? The empty space average will grow. If you are increasing production, then that's a different question altogether. But right now, do I require another ferry or a new ferry or any extra accommodations? No. That's it. That is all that they're expecting from the question. And I've told you, this is the pattern it always follows. And that is, you have data. Now in this case, in the previous case, data was, I think, weekly sales or weekly production or weekly demand, whatever that is. This is daily production. And the probability of that production, we found a range. With the help of that, we estimated, we simulated, we imitated the production for the next 15 days. And after this, they will ask you, they might have finished the question here by saying, tell us the average number of, tell us the average production per day. I would have added the production and divided by 15. That's it. Or they might say that what is the number of or in this question, they have asked you something extra. So with every question, this part will change. What extra are they expecting out of you? Everything else will remain the same. That's it. Let's look at their solution quickly. So in their solution, table number 1, production per day, probability, cumulative, range. After that, let's start predicting production for the 15 random numbers. And then they have cars waiting to be shipped and empty spaces. The columns have been inverted. I've drawn this first and this last. That's okay. So the total number of cars waiting is 6. Empty spaces is 18. So average number of cars waiting to be shipped is 0.4 per day, while average number of empty spaces is 1.2 per day. They have not asked you to conclude this in any day anyway, so there is not going to be a conclusion. This is going to be my final answer. The next question that I want to do is this. It's a little different because there are 2 sets of probabilities. So what does it say? Titfit Scientific Laboratories is engaged in producing different types of high-class equipment for use in scientific laboratories. Okay. The company has 2 different assembly lines to produce their most popular product, pressure. The processing time of each of the assembly line is regarded as a random variable and is described by the following probability distribution. So, see, processing time from 10 to 14 minutes and the probability of that processing time on assembly line A1 and the probability on assembly line A2. Using the following random numbers, generate data on the process times for 15 units of the item and compute the expected processing time for the product. For the purpose, read the numbers vertically, taking the first 2 digits for processing time on assembly A1 and the last 2 digits for processing time on assembly A2. So they are asking you to read the random numbers vertically. So read them as 4134, 7476, 4943, like this vertically. But sir, random number you said is only 2 digits. Agreed. What they've done is they've brought 2 pairs together. So 4134 means 41 is for assembly line 1 and 34 is for assembly line 2. They have given you together so that you don't mess it up. Everybody should take it in the same manner. 41, 34. And they have asked you to do this for 15. Are there 15 random numbers? 3 rows with 5 columns is 3 5s are 15 random numbers. So let me understand the question. You are trying to tell me that you are producing a product called Pressure X that has to go through 2 assembly lines, assembly line 1 and assembly line 2. Now I have set a few standards, but it is not always that it takes exactly that standard time. Maybe there is some element which is like a human intervention into the production of that commodity, because of which what is happening is it takes least 10 and maximum 14 minutes. And both the assembly lines have the same least and maximum 14. They could have different tables altogether, but they put it in one table. What I'm going to do is I'm going to split it and make 2 tables out of it. What do you want me to do? You want me to use the 15 random numbers that they've given you and create an average production time, or give you an average production time of that product. Okay, then you know the process. Let me get the tables ready. So the first column there is the processing time. The second column is the probability of A1 and the third column is the probability of A2. So what I have done, I have created 2 different tables. I'm going to name this A1, I'm going to name this A2. So everything for assembly line 1 will happen here, assembly line 2 will happen here. What all do I require? Number 1, process time. 10, 11, 12, 13 and 14. Well, the same thing here. Process time. 10, 11, 12, 13, 14. After that, I have probability. Probability. Now the processing times are the same, but the probabilities are different. 0.1, 0.15, 0.40, 0.25, 0.10. The probabilities here are 0.20, 0.40, 0.20, 0.15 and 0.05. Now my next step will be accumulating these probabilities. So here it will be 0.10, 0.25, 0.65, 0.90 and 1. Now here it will be 0.20, 0.60, 0.80, 0.95 and 1. Now I haven't drawn that imaginary column where I told you in your heads multiply by 100, because now that we are in 2 or 3 questions, you know what we are supposed to do. So range and range. So if I multiply this by 100, this is going to be 10. So this will be 0 to 9, which means this will start at 10. 0.25 basically 25, 24, 25 to 64, 65 to 89, and then lastly 90 to 99. Let's come here. If I multiply this by 100, this will be 0 to 19, because this will be 20, then this will be 20 to 59, then this will be 60 to 79, this will be 80 to 94, and this will be 95 to 99. Done? What I've done is I've already kept the next table ready. So what are we going to do? With the given random numbers, I'm going to estimate the time of 15 products on assembly A1 and assembly A2. For that, I need what? I need my next table, and that is product number. So product number will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Then there are 2 assembly lines. So first, for assembly line A1, there will be a random number, and according to that random number, there will be a predicted process time. Similarly, for assembly line A2, will have its own random number and will have its own processing time. Let's begin. Let's first write down the random numbers according to what they have given us. So let me do 2 things. Number 1, let me unzoom this a little so that everything fits on one page. Perfect. And let me pull out the random numbers. Well, these are the random numbers. How are you supposed to read them? Vertically. And when you are reading them vertically, how are you supposed to read them? Well, the first 2 have to be for assembly line A1 and the next 2 have to be for assembly line A2. Okay then. So 4134 will be 4134. 7674 will be 7476. 4943 4943. Next column 8343 8343. Then you have a 1183 1183. Then you have a 1915 1915. 3602 3602. 94 45 54 15. 75 05 00 89 08 80 74 28, 34, 24, 93, 0, 9. Now that I have written the random numbers, according to these random numbers, I have to predict the time on the two assembly lines A1 and A2. Okay, done. 41, 25 to 64, 12. 74, 65, 89, 13. 49, 25, 64, 12. 83, 65, 89, 13. 11, 11. 19, 11. 36, 12. 94, 14. 54, 12. 75, 13. 0, 10. 8, 10. 74, 13. 34, 12. 93, 14. Let's do this for assembly line A2. 34, 11. 76, 12. 43, 11. 43, 11. 83, 13. 15, 10. 2, 10. 45, 11. 15, 10. 5, 10. 89, 13. 80, 13. 28, 11. 24, 11. 9, 10. So I have predicted the time that all products will take on assembly line A1 and then on assembly line A2. Now let me do a thing. Let me check what is the total time the product will take. The product number 1 takes 12 minutes on A1 and 11 minutes on A2, which is a total of 33 minutes. Sorry, 23 minutes. Here it will be 25. Here it will be 23 again. Here it will be 24. Here it will be 24. Here it will be 20. Here it will be 22. Here it will be 25. Here it will be 22. Here it will be 23. Here it will be 23. Here it will be 23. 13 plus 11 is going to be 24. 12 plus 11 is going to be 23. And 14 plus 10 is going to be 24. Let's do one thing. Let's take an average. But for average, I first need to take totals. So I will draw another column which I already have ready. And that is total. So total for assembly line A1 is 12 plus 13 plus 12 plus 13 plus 11 plus 11 plus 12 plus 14 plus 12 plus 13 plus 10 plus 10 plus 13 plus 12 plus 14. And the answer is 182. Let's check for assembly line A2. For assembly line A2, we have 11 plus 12 plus 11 plus 11 plus 13 plus 10 plus 10 plus 11 plus 10 plus 10 plus 13 plus 13 plus 11 plus 11 plus 10 is a total of 167. So the total of totals will be 349, the total of both together. So either do this total or add these two up, same. Let's write down our averages. So average times I'm making a table on A1, on A2 and total. So average time on A1 will be 182 by 15. Average time on A2 will be 167 by 15 and total will be 349 by 15. So 182 divided by 15 is 12.13333. 167 divided by 15 is 1.13333 and 349 divided by 15 is 23.2667. And that's going to be my answer. So the average time it takes on A1 is 12 minutes, A2 is 11.1333 and both together is 23.266. So on an average I can assume an estimated production time of 23.2333. Isn't this like time and motion study? Well, you are doing the same thing repeatedly over and over again and then eventually taking an average, but in a slightly different way. That's it. Let's check their answers. So they have yes, 182, 167, 349, 12.1333, 11.1333 and 23.27. So they've also written it properly, which also tallies by adding these two also. So both give you the same answer. Nothing wrong or nothing different about it. That's it.